So evaluate the integrals of x squared over root of 1 minus x squared from 0 to 1. So the integral of this function, we can see it's easy for us to use trigonometric substitution, where we have to substitute this one with a let x to be what? A sine theta. Since 1 minus sine squared theta, it can give us what? Cos squared theta. So we want something that maybe when you use trigonometric substitution and a square root, then if it is possible for you to obtain 1 minus sine squared theta, it's nice and good, because after then 1 minus sine squared theta is just cos squared theta, and the root of cos squared theta, you can obtain it, so it's possible. Now how can we, now we want to substitute, how can we get the value of a? We say that the square root of a squared minus x squared is when we use a sine substitution as x being sine of theta. So why do we substitute with a sine theta is due to that 1 minus, when sine is squared, 1 minus sine squared, 1 minus sine squared should give us what? Cos squared. That's why we have substituted with sine theta. Now how can we get now our a from this function? So our a there is now squared. So our a squared in our function is 1. Meaningly, getting a, we have to just take the square, whereby the a, it will also be 1. Therefore x, it will be just sine theta. That it will be our x. Now let's come to our question. How to substitute there now? We just say if x goes to sine theta, therefore differentiating this function in terms of theta to be dx d theta to be what? Cos theta. But we want dx, since in our we want to substitute dx there, therefore our dx should be what? Cos theta d theta. That is our derivative. So we can substitute dx with this function. Now let's substitute it also in this root. So it will be just let's ignore this one first. So let's simplify it, then we'll come back to integrate. So it will be x squared over what? The square root of 1 minus, wherever we have x, just substitute with sine theta. So it will be, so x squared sine theta squared will be sine squared theta. So dx to be cos theta and theta. But the square root of 1 minus sine theta, it will be just square root of cos squared theta, cos theta, theta. So the square root of this one, so the square root of cos squared theta is just x squared over what? Over cos theta. Then the theta, cos theta, the theta. But cos theta will cancel out here. So we just remain with the integral of x squared, the theta. So since we substituted x with sine theta, then x squared is just the integral of what? So x squared is to be just the integral of sine squared theta, the theta. So the integral of sine squared theta, it will be what? Assuming this one, so this one to be just sine of theta squared, the theta. We know that it is somehow difficult for me to differentiate sine theta. There is no, it's very difficult for me to use those techniques to differentiate such a function. So we can write this function as being sine squared of theta, but sine squared of theta we can write it being like this: 1 a half minus a half cos theta. This one is mathematically correct, the theta. Then we can come now and find the derivative of this one. So the derivative of this one will be just, it will be just, when you differentiate, this one is a constant, so it gains theta. So minus the derivative of this one, it will be just a half of what? So it will be plus, since the derivative of cos theta is minus sin theta. So it will be plus sine of theta. So plus constant for limits of 0 to 1. But earlier we had substituted that x equals to sin theta. So we can come back to this, our trigonometric. So assuming this one to be theta, therefore this will be my opposite and this one it will be my hypotenuse. Therefore my adjacent will be just the square root of hypotenuse, the square root of hypotenuse squared minus this side squared. So getting theta, it is possible. So it's just the sine inverse. So theta here is just this sine. So our theta is just the sine inverse of what? Of x. So we can come and substitute our theta, being a half multiplied by sine inverse of x. So minus a half sine theta. So sine theta is just opposite of a hypotenuse. So sine theta, we can say sine theta here equals to x. So sine theta equal to x over 1, which is x. So sine theta we just substitute with x. So from 0 to 1. Therefore we can come and finish it by substituting with 1 and final with 0. So it will be just a half sine inverse of 1 minus 1 minus a half sine inverse of 0 minus 0. So a half sine inverse of 1 minus 1 minus a half sine inverse of 0 minus 0. So after substituting, then you just take your calculator, you just key in shift, then sine 1. When you shift sine 1, it automatically gives you 90. Then a half of 90 is 45. So 45 minus 1, it's just 44. Then minus sine inverse of 0, 0, a half of 0, then minus 0, just it will just be 0. So 44 minus 0, which it will be what? 44.